Good day everyone, I'm Joanna Francesca Ferraren from Group 3. We are here to present our group project entitled Temperature Humidity Monitoring System using Arduino. In today's world, knowing temperature and humidity around us is very important. For example, too much heat or humidity can affect our health, damage electronic devices, and even spoil food. That's why we decided to create a simple system that can monitor and display the current temperature and humidity in real time. Our goal is show how Arduino and sensors can be used together and display environmental data easily and accurately.
My name is James Pagaduan. Now let's talk about the components and how the system works. And meron po tayo dyang Arduino Uno and LCD display. Tapos breadboard, tsaka may sensor po tayo dyan ng pang temperature. Tsaka may female wire po tayo dyan. Tsaka cable po. Tsaka ito po paano gumagana yung temperature po namin. Ayan po, gumagana po siya, umap. Ayan po.
Wala talaga.
Ayan po, tapos ayan, makikita niyo po. 25, tapos pag lumalamig po, bumababa siya. Ayan.
Hello, my name is Francesca and let's talk about benefits and conclusion. This project may look simple, but it has many practical uses. It can be used in homes, classrooms, greenhouses, and storage areas to help maintain good air conditions. For example, farmers can use it to monitor humidity level for their plants, or homeowners can check the temperature in their room. We also learned a lot while making this project, especially about programming the Arduino, connecting sensor, and displaying data. It showed us how electronic and coding can work together to create something useful. In the future, we can improve this project by adding IoT features so the data can be viewed on the mobile app or website. That way, user can monitor temperature and humidity remotely. To sum it up, our project is a simple, affordable, and educational way to understand how monitoring systems work. Thank you so much for listening to our presentation.
Good evening, Ma'am Carissa. I'll be explaining our code for tomorrow's presentation. And let's get started with the includes. We also got that from the library, as you can see here, that we installed a lot of it, so we can connect all of these codes together. And next, let's talk about the liquid crystal I2C. Controls the I2C LCDs using your 16x2 screen, what you saw at the video a while ago, the LED, and the wire H required for I2C communication used by the LCD. Other fruit sensor in .h and DHT.h and DHT underscore U.h libraries for reading the DHT sensors, and you can see it here. And let's go next with the 0x27, the address for the LCD. That is the most common for many modules. LCD has 16 columns and 2 rows. Here are the 16 columns and 2 rows. And also next is the define DHTP A3 until DHTP pin, DHTP type. The Arduino pin connected to the DHT11 data pin tells the library which sensors you're using, and also creates a DHT object to interact with the sensor. And as for the float H and float T, here, as you can see here, H is the humidity, and T is the temperature. Shorter explanation is that's where they sense all the humidity and temperature. And lastly, not lastly, I mean the next one is serial begin. And here you can see where start serial communicate at 9600 Mbps and initialized by DHT sensor, initialize the LCD, turns on the LCD backlight, sets the starting position for printing text, column 0 and 0. Wait, and you have to wait for 2 seconds and clears the screen before the main loop. Okay, now let's head to the if statement. Checks if the reading failed or reading has secured. As you can see here, this is the checking if reading failed for the whole code and shows you the correct reading here. You can see if the temperature is too hot, too low, or too high. And as for ICD set cores, temperature in Celsius are char 223. Prints the symbol. Humidity is the percentage. And this next one is the serial print humidity, useful for debugging or logging values on your computer. You can use this for debugging to see what is wrong with the code inside, and you'll see it here in the output if you scroll up. But we didn't run the project, so you wouldn't see right now. Delay 2000. The HTTP should not be read faster than every 2 seconds, because it would wreck the code and would not initiate if it doesn't read for 2 seconds, because everyone needs to process, even AI. So that's it for today, ma'am.